Question 14 is coming from circle theorems and properties. A, B, C, D, and E lie on a circle. FG is a tangent to the circle at C. Angle BAD is equal to 110. Angle ADB is 20, and angle BCE is equal to 45 degrees. Part A, find angle BCD. Give a geometric reason for your answer. Angle BCD, where do we find it? This is BCD. This is the angle here. Okay. Now, if we look very keenly, this is A, this is B, this is C, this is D. This is a cyclic quadrilateral because the vertices of it are on the circumference of a circle. And this angle here with this one here, when added, they give us 180 degrees. So I will say that angle BCD, I will say angle BCD is equal to 180 minus 110, which gives us 70 degrees, because then I say angles, not just angles actually, opposite angles. So we say opposite angles in a cyclic quadrilateral add up to 180 degrees. Then part B, Roman 1, find angle DBC. Angle DBC. So the one they want is actually this one here. Now, there is something we need to recognize here. If you look at point B and point C, and then you follow this one here, there is this angle which is formed at the circumference here. This is 45 degrees, okay? Then come back to the same point B. Then you again follow this chord here. Then it goes and meets D here at the circumference, then comes back again to C, okay? Now, in circle theorems, we have, if you have this arc here, comes like that, then comes to this one, then also this to that. These angles are the same. We say angles by the same arc in the same segment are equal. Now, that means this one here is 45 degrees. You see that? So if that one is 45 degrees, and we have gotten this one as 70, okay, then this implies that to get this one in question, we shall just get 180 minus these ones that we have. Okay, so I will begin by writing about angle BDC. So I will say angle BDC is equivalent to is equivalent to 45 degrees. Why? Angles in the same segment are equal. Angles in the same segment by the same arc. Suppose they had asked us the geometric reason, just like up there. The same segment are equal. Okay, then 100, this angle DBC shall be equivalent to 180, then minus this 45 added to the 70 we got up there. So this 70 plus 45, that is 115. Then when we subtract 80 minus 15, isn't that a 65? Yes, that's 65. So this one is 65. Then Roman 2, find angle DCG. Let's check here. DCG, allow me first clean up everything here. Angle DCG. D is here, C is here, D is here. Angle DCG, this one here. If I recognize the segment within which this one is, then I can see that with this tangent, there is this point C, then point D here, and point B. They form a triangle. So I look at the angle which is opposite to that segment, okay, within which this angle lies. So this angle that is here is always equal to this angle here. So if this is x, then even this one will be x. That is what we call alternate segment theorem. So this simply implies, remember we have gotten this angle here as 65. That means even this one is going to be 65 degrees. My answer here is going to be 65 degrees. Angle DCG is equal to 65 degrees. The reason is alternate segment theorem. So I'm going to write all these geometrical reasons such that you know where the answers come from. Okay, so here they just told us to give the geometrical reason. Here they didn't ask us, but you need to have these geometrical reasons to be in position to answer.